G'day! In this race, because the race car is much faster than the motorbike, the race organiser gives the motorbike a head start. To work out the time when the car overtakes the motorbike, we solve two linear equations simultaneously, that is, at the same time. All we need to know first is both speeds and both starting positions. But what does solving simultaneous linear equations mean? Well, the car and the motorbike each have an equation that shows their speeds and their starting positions. When we graph these, they are linear. They're straight lines. We'll look at those closely in a moment. The car and the bike race simultaneously, that is, at the same time, so we work out their equations at the same time. Solving means that we want to find the time when the car and the bike are together in the race, that is, when the car is about to overtake the motorbike. Now let's look closely at the two equations. The equation for the bike is y equals 50x plus 200. X is the time in seconds, y is the distance travelled in metres. 50 means that the bike has a speed of 50 metres per second. That's 180 kilometres per hour. 200 means that the bike starts 200 metres ahead of the start line. The equation for the car is y equals 100x plus 0. X is the time in seconds, y is the distance travelled in metres. The 100 means that the car has a speed of 100 metres per second, that's 360 kilometres per hour. The 0 means that the car starts right on the start line. Let's construct tables of values and then draw the graphs of these equations. The tables of values have an x part and a y part. In this example, the x is the time in seconds and y is the distance travelled in metres. Let's work out how far the bike goes in 5 seconds. At 0 seconds, that's the start, the bike is 200 metres ahead of the start line. After 1 second, the bike is 50 times 1 plus 200. That's 250 metres. And so on. We'll do a table of values for the faster car. At 0 seconds, that's the start. The car is right on the start line, so it's at 0 metres. After 1 second, the car is 100 times 1, that's 100 metres, and so on. Now look at this. Both the bike and the car are 400 metres from the start after 4 seconds. The value for the x and the value for the y fit both equations. Let's see what their graphs look like. Time goes on the x-axis. Distance goes on the y-axis. First, let's graph the bike. At 0 seconds, the bike is 200 metres. At 1 second, it's 250 metres, and so on. Then we graph the car. At 0 seconds, the car is 0 metres. At 1 second, it's 100 metres, and so on. Remember that the table shows that at 4 seconds, the bike and the car are both 400 metres from the start line. That's where the graphs cross each other or intersect. We've just solved these two equations simultaneously by graphing. The answer is that the car will overtake the motorbike after 4 seconds and at 400 metres from the start line. In this second example, which car rental company has the better deal? What do you think? Let's use math to work it out. First, we write the two equations. X is the time in hours, y is the cost in dollars. Now, Yellow Company charges $25 per hour to rent a car, but you pay no deposit. The yellow equation is y equals 25x plus 0. The Red Company charges only $20 per hour, but you have to pay a deposit of $10. The Red Company's equation is y equals 20x plus 10. Let's construct tables of values and then draw the graphs of these equations. X is the time in hours, Y is the cost in dollars. Let's work out yellow car's rental cost. When you turn on the ignition, it costs nothing at all. After 1 hour, the cost is $25. 2 hours cost $50, 3 hours cost $75. Now for the red car rental cost. When you turn on the ignition, it already costs the deposit of $10. After 1 hour, the cost is $20 for 1 hour plus the $10 deposit. That's $30 altogether. After 2 hours, the cost is $40 for 2 hours plus the deposit of $10. That's $50. And 3 hours cost $60 plus $10. That's $70. Notice that both companies have the same cost of $50 for 2 hours of car rental. The value for the X and the value for the Y fit both equations. Now let's draw the graphs and see where the graphs intersect. First we draw the yellow graph. 0 hours matches with $0, 1 hour matches with $25, and so on. Now for the red graph. 0 hours matches with $10, 1 hour matches with $30, and so on. Remember that the table shows that at 2 hours, both companies have the same cost of $50. The graphs intersect where the value of the X and the value of the Y fit both equations. That's the solution. We have just solved these two equations simultaneously by graphing. Which is cheaper? Well, a cheaper company up till 2 hours is yellow, but after 2 hours, red company is cheaper. Thank you for watching.